Okay, so we're going to go with red, which is 8. Ah, oh no, I just ruined it. Okay, hello my friends. Hopefully my microphone and audio and lighting is working okay. It's a little bit cold and dark where I am in Canada right now. Minus 40 centigrade Celsius, sorry. And yeah, it's pretty cold. So wherever you are in the world, I hope you're warm. Anyways, today we're going to be starting Snake with PICO8. I think it'll be a really fun lesson. All right. So as you can see, I've got the PICO8 fantasy console up and running. I'll just quickly reboot it just because I enjoy hearing the opening chime. There we go. There. Now that I know we're going to have a lot of fun. Okay. So let's take a look at what's in our folder. ls or dir also works, and it shows us the PICO8 files that are right in our folder. Now I've got an old backup of Snake as well as some other demos and Hello World, those kind of fun basic things. So let's start a brand new file. And how do you do that? You type in save and then whatever file name you want to call it. Let's call it Snake. And you leave off the file name. PICO8 will fill that in for you. Booyah, there we go. Snake.p8. All right, and now if you hit escape, you get into your friendly editor. So let's just put some comments at the top. Snake game. Fun for the whole family. For sure. Who doesn't like Snake games? All right. So first what we're going to do is, oh, how did that mouse appear there? Anyway. Popped in out of nowhere. Okay, so first of all, let's get in our familiar PICO8 functions that are standard in every single PICO8 app. So we are going to just type them in now. They are, oops, I always do that. Init, and we have update, and we have draw. It is draw. Okay. I get confused between draw and render. So sometimes it's render. Whoops, I keep doing that too. So you might notice as we're typing that I tend to unconsciously hit the subconsciously hit the shift key a lot while I'm typing in letters. Oh my gosh. Because as you can see on the code editor display here, everything looks capitalized. So in my brain, I'm also trying to capitalize everything that I'm typing in once in a while. So I'll try and edit those out just so it doesn't get too annoying. But let's move on. All right. So in our draw loop, we first want to clear the screen every single time. So every single time our game runs, we want to clear the screen. And I want to clear it to this same navy blue background color that we see right now in the editor. Let's see what it looks like black. And so let's hit Control S to save it, and then hit Escape to go back to the command line, and then run. And as you can see, we get a black screen, all right? So hit Escape again to stop it, and hit Escape again to go in the editor. So let's clear our screen, let's clear our background to this nice navy blue color that we're seeing right now. Save it again, hit Escape, hit Run. Ta-da! All right, now you know we're on our way. Okay, so hit Escape and then go back into our editor. And so what we want to do is, I'll try and talk about the basics of Snake as we go through everything. But we want to, I think the first task here is going to be to just have the snake head that moves around. Okay, so let's create a function here under draw called draw snake. And we'll fill this in, of course. And in our update function, we'll take in our keyboard, whatever keyboard key that we're hitting, and adjust the position of our snake head accordingly. But we won't be doing that yet. First, we're just going to be looking at how to draw this thing. Okay. So first, what we're going to do is, okay, move ourselves up there. Okay, so we are going to be using something in Lua called tables. But if you've seen other languages like JavaScript, then tables kind of look like JavaScript objects or even plain Ruby objects. There's a lot of nuance to them. I'm sure it's not that simple to work with, but let's just bear with me while we start it out. So those are the empty close and open curly braces. So we're going to have an X and a Y table, what Lua calls table. Okay, we'll start with this, and then we also want to decide how large our snake game is going to be, how much screen size it's going to take up. As I mentioned before, we have 127 by 127 pixels for our resolution. So I think what I want to do is I want to try and fit 32 of our pixels across the screen. And you'll see what I mean as soon as we start to work with it. So our tile size, our actual tile size of each pixel of our snake, each segment of our snake, and the segment of our, not segment, and the size of our apple or fruit is going to be 128 divided by the number of tiles. So tile num. And hopefully, as I said, I can cut to me on some paper drawing this out for you. Okay. And then let's also keep track of our score, just to have a little bit of fun. Okay. So down in our draw method, after we draw the snake, we're going to draw our score. Just because score is so nice and important to get out of the way first, right? So let's create a function, draw a score. And what we're going to do is change our color to yellow. Basically, we use the color command to change the color of the pen that we're going to be using to draw things. And we want to make it yellow, so we pass in a parameter of 10 for yellow. And we want to print, whoops, I did it again, score. And then we want to append our actual score. And then we want to draw it at right in the top left corner, 1, 1. And let's go end. And then for now, let's put in our draw snake. And we'll make it empty. We'll save this, hit escape, and we'll test this again. Run. There we go. Background is cleared, and we've now got a score of 0. Hit escape, we're back in there. All right. So let's now set up our snake. So in the init, let's create a method here. We're going to go back to our x x table, as they say in Lua, and in Lua, unlike just about every other language, which might confuse you when you first look at it, the indexes for arrays are 1. The first element starts at 1. It doesn't start at 0. So it might confuse you a little bit if you're used to seeing other languages where the first element is always, x of 0 is the first element normally. But in Lua, it's x of 1. So what we're going to be doing is we're going to set it to our tile size. So tile num divided by 4. And this is just creating a spot where we start the snake head. That's all we're doing. So times tile num divided by, 2. Let's give it some, maybe we'll create a better way to set it up later. Okay, but now in the draw snake, let's do I think what I want to do is a rectangle, or a rect fill, sorry. So let's do a rect fill. What we want to do is take a filled rectangle, and the rect fill function takes in the x and y coordinates that you want to draw it at, and then how wide and how deep you want to make that rectangle. Basically, how big you want to draw your rectangle. So we're going to be passing the x of 1 position plus the tile size, and the y of 1 position plus the tile size. And then we're going to be using the color 3, like I said, for green. Okay, so that's out of the way. We've got the score, we've got the snake. Okay, so now what we want to do is update the snake. So we want it to move. So first, we are going to make a function called update snake. And then once we draw this, we are going to be going over keyboard input to look at how to control it. Okay, so we'll keep all of our draw methods, all of our draw functions together, excuse me. And then we'll add one here for update snake. And okay, so let's see, what do we want to do here? So in Lua, there is a concept of global and local variables. So these variables up here, this tile num, tile size, score, these are all considered global variables in Lua. But once in a while, you want to work with variables that are only local to the function or the block of code that you're working on, in which case it won't interfere with the existing variables that you have globally. And what we're going to do is we are just going to simply update the position of the snake head every frame. So our x of 1, we'll add it to the direction, the x direction that we're going in, times the tile size. And the same thing with y1, plus equals y dir times tile size. Whoops, not title size. Tile size. Now, if you've never used the plus equals operator before, it is a shorthanded version of saying something like x equals x plus 1. So x plus equals 1 is the same thing as x equals x plus 1. It's just an easier to read shorthand. Let me know in the comments if you don't like shorthands and you want to see everything kind of written out. If that helps you learn better, I can certainly switch to that. I don't mind at all. Okay, so now we have two new variables here called xdir and ydir, which is storing our directions. So let's put those up here in our lovely global variables list. And we will initialize them to 0. I think in our init snake, let's initialize xdir to 1. Okay. So now we update every single frame. Xdir is going to be set to 1. So Xdir is set to 1 here, and we're not changing it. So this means that once we save this and run it, we're just going to be moving across the screen until the until the green snake blob disappears. Okay, so save it, Control S. Now hit escape, and then type in run. And there we go. We've got our snake head whipping away out of the screen. So hit escape to stop things. Hit escape again to go back in the editor. All right. So let's see here. So what we need to do now is grab our input and check the state of our keys. So let's call this update input, maybe, just to keep everything consistent. Update input. And we'll go up to our update section. Okay. I comes before S. And let's type in function update underscore input. So here what we're able to do is we are going to be scanning, well, not we, but PICO8 is going to be scanning the keyboard every single time that this function is called. So pretty much every frame. And then it will record the state of the keyboard, and then we'll update the position of the snakehead depending on the state of the keyboard. So PICO8 comes with several predefined button directions. So button 0 is left. We want to move left. Button, so it's the left arrow is button 0. Button right, or button 1, sorry, is moving right. Button 2 is the up arrow, and button 3 is the down arrow. Okay, so let's give ourselves some room here. All right, now let's do, so if, so what we want to do is check the state of button 0 first. So if we hit the left key, okay, or left arrow, sorry, not left key. So if we hit the arrow, so if button 0, okay, then we want to move left. So xdir equals -1. And we want to make sure that y_dir is also 0. Okay. And else if button 1, then, so we've hit now right. So x direction is positive because I should have explained, or okay, hopefully past me explained this properly. When we are moving across the screen from left to right in PICO8, we're moving from lower to higher x values. And so when we're moving in the other direction, we're going from higher to lower x values. So we have y, and then similarly, when we're going upwards, we're going in a negative y direction, and when we're going downwards, then we're traveling in a positive y-axis direction. It'll make sense as you play with it, and I encourage you to play with it as you go through our snake game right here. And maybe we'll do this right after this. We'll have a little bit of extra fun. We'll switch the directions around, and I'll show you what will happen. Okay, so now we're going to hit up. So if we go up, then our x direction component is still 0. Our y direction component this time, we want to move, as I said, -1. And then finally, else if button 3, so we hit the down arrow, then we're not traveling in the x, or in the horizontally, so the x direction is 0, and we're going to set the y direction to +1 because we're traveling in the positive direction going downwards. Hit end to make sure we're done our end, and then end to make sure we're done our function. Okay. Oh, we already had another end here, so let's get rid of that extra end. And just in case I didn't mention it previously, all the source code should be linked to from this video, so feel free to download it from GitHub as you're following along, and maybe it'll make more sense as we're going through it, and hopefully won't have as many typos as I do right now. Okay, so let's comment these out. We use the double dash or double hyphens to comment lines out in Lua. And let's save it, and then let's see if this works the first time. Hit escape, hit run. Okay, so I'm hitting the up, left, down, right arrows, and we're traveling in the proper direction. Right on. Okay, so let's hit escape, let's hit escape. Now let's fiddle with these just to show you, just maybe to help illustrate the direction I was talking about. So let's swap the y values, and let's see what happens. So let's save it, hit escape, run. And then now, oh, that screwed me up. Okay, so when you hit up, we go down, and when you hit the down arrow, you go up. See, I've already lost it. Okay, let's put these back in the right way. Okay, so we've got our update, we've got our score being printed, we've got, oh, now we need to draw our fruit. So let's draw some fruit. And we will create another table object for fruit. Fruit. Okay. So fruit equals an empty object there. Okay, so fruit equals an empty table, so an empty open and close curly brackets. Okay, and then what we're going to do is we're going to assign an x value, which is where our x coordinate for our fruit. We'll give it 0 right now. We'll create a y value, 0, and we'll even do a color. Let's go fancy. And I think red is 8. I'll show you the color chart. So here are the colors. Don't those colors look amazing? So I'll link it in the description down below, but you'll see here, so we remember in the beginning we created a background clear of black, which is 0. And then 1 is our navy blue. And you can see the rest of the color palette here. Okay, so we're going to go with red, which is 8. Ah, oh no, I just ruined it. Okay, there we go. I won't touch that browser window again, folks. Okay, our fruit color is now 8. Okay, so now what we want to do is we do want to update the fruit. And so by updating the fruit, what we're going to be doing is placing it. So let's call this one, so function update fruit, and then let's go through it together. Okay, so what we are going to do is we need to use the random method in Lua to just grab a random x and y to put the fruit on. So let's do fruit.x equals, and so what we're going to have to do is take the floor, random, and we're going to be taking the number of tiles across because that's the possible number of x positions that we can go in. And we're going to multiply it by the tile size, if I could spell tile size correctly. All right. And then fruit y, we're going to be doing the same thing. So we're going to be taking the floor, just because random, what we want are integers. So we want whole numbers coming back. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Instead of something like 1.5, 1.2, 1.8. So random usually works between a 0 and 1 sort of thing. And then we multiply it out to make sure that we're getting a random number, a random whole number between 1 and 32, I believe. Okay, so let's do number times tile. So basically the exact same line twice. All right, so update fruit. There we go. So now let's go down to our update method. Or no, we won't. Let's go to our init method. Okay, so the first time we run, we're going to generate the fruit. So update fruit. Okay, and then let's create a draw fruit. So let's go F before S, function draw fruit, end, and we're going to be drawing another rectangle. So we'll do a rect fill, another filled rectangle. We're going to be doing fruit.x and then fruit.y, and then fruit.x plus that same tile size, and then fruit.y plus that same tile size amount, and then the fruit.color. Okay, so now let's go down to our draw command, or our draw method, sorry. So we want to draw the snake, then the score, and let's draw the fruit in between that. Okay, hit save, and then hopefully hit escape, type in run, and there we see the fruit on the top of the game there. Let's run it again, and it's showing up in different spots all over our game board. All right, that is pretty cool. Okay, so we can move, or we can draw our objects, we can move them, we can control them with our arrows. So now let's go over collision detection. We're going to have to know when our snake head hits our fruit and then updates our score. So let's hit escape again to go back in the editor. So we want to calculate a collision between our snake head and our fruit. So luckily we have all of the positions we need to do that calculation. Okay, let's call it function is fruit collision. Terrible name, I'm really sorry. But it's basically just to test. We're going to be returning true or false if our snake head is in the same position as our fruit, our piece of fruit. And if it is, then we have a collision. Okay. So if our x of 1 plus our xdir times our tile size is equal to fruit.x, and our y of 1 plus y_dir times tile size is equal to fruit.y. Then we have a collision. So return true. And then otherwise, just return false. You can also make that an else return false, but I like doing it this way. Okay. So basically, if our x position of our snake head and the width and height, basically we're creating a small rectangle that's the same size as our snake head piece. And if that snake head piece is matching the same position and size of the fruit piece, then we call that a collision. All right. Hopefully I explained it properly there. Okay, so now so we do the update, and then before we update the snake, let's test if we've done a collision. Okay, so we'll create another local variable. We'll call it collide equals false. And then we'll set collide to be is fruit collision. Okay, so if it did collide, so if collide, then let's put some, then we want to increment our score. So we can do plus equals again, or if we want it written out the long version, let's do that. Score plus whatever number of points you want to give it. Let's give it 10. You can make it 25, you can make it 50, 100, whatever kind of scale you want to do. Okay, and then we want to set our x of 1 position to be the same as fruit.x, and y of 1 to equal the same position as fruit.y. And then we want to update the fruit to calculate a new fruit position. And then, okay, else. So if we didn't collide, if there is no collision, then just go ahead and update the snake as we've been doing this whole time. And end. Okay, let's see if it's this easy. Hit escape, hit run. Maybe I'm missing an extra. Okay, so if. So we've got one set of brackets around there, and then y, and then another set of brackets around there. Oh, okay. Then we need closing set of brackets. Okay, Control S, hit escape, run. Oops, okay. I gotta remember to keep my feet, or not my feet, keep my hands on the arrows here. Okay, so let's see. Oh, okay, our score went up. We're now colliding with the fruit. When we get there, going up to 30, 40. Okay, good. Nice, nice. Okay, so hit escape again. Let's go back. Okay, so now let's draw the snake tail. And let's do a standard snake game where our tail will grow with every time we hit the fruit. So now we get to do loops. Loops in Lua. That's how this is going to go. Okay, so first of all, we're going to do the updating. We're going to be going into updating the snake. So our update snake method. Okay, so we've got our, this is updating the position of the head. Update snake head. All right. So what we want to do first is we're going to need to store, create some temporary variables and store the position of each snake tail piece, and then update them every single frame as we update the position of the snake head piece. So I'll show you what that looks like. So first, let's create some local temp variables to store these temporary positions. Okay, so local temp x, I'll just call it temp1x, equals x of 1. We'll store the current position of the head. Local temp2x equals y of 1. Okay, and then we want to also have, oops, 1y. Okay. And then 2x, and then temp2y. There we go. Okay, so first we update the snake head, which is what we do right here. And then we update the snail, update the snake tail pieces. Update the snake tails. Snake tails, woo! Okay, enough of that. So what we want to do is a for loop. Now in Lua, a for loop is where we want to count either going upwards or downwards through a number set, a number range. So let's say we want to iterate between 1 and 4, which means 1, 2, 3, 4, or we want to go downwards from 4 back to 1, so 4, 3, 2, 1. And so what we need to do is, so we want to set our looping variable to start off at 2, because we're now referencing the snake tail segments and not the snake head. So the snake tail and the pound x, I know that looks like a weird character here in PICO8, but the pound x character here means we want to go through the entire table that are storing snake segments. Okay, and then we want to do, so every 4 has a do. So what we want to do is first store the position of our current x and y. Y, I. And then what we want to, oops. Okay, so that should be 2x. Because otherwise we're just overwriting what we stored just previously. Okay, and then our x of I equals, oops, our temp1 x position. Oops, I didn't even call it x. Okay, temp1 x. And then y of I equals temp1 of y. And then what we want to do is temp1 of x equals temp2x. And temp1y equals temp2y. And end that off. So here we should be updating the position of every individual snake segment piece after the head is done. Okay, so now we're updating it. Now let's draw it. Okay, update fruit. Oh yeah. Draw is after. Why did I put draw? Update before draw. Anyway, I tell ya. Okay, so we want to do. Okay, so we want to do a similar loop for when we're drawing out the snake segments. So for I equals 2, and we want to go to hashtag X. And I think I missed a, no, I got it, a comma. Okay, I got it there. So 2 hashtag X, 2 to the length of X, do. And we want to do another rect fill. So rect fill, and then we want to do X of I and Y of I. And then X of I plus tile size. And Y of I plus tile size. Oops. Tile size. And then for now, we'll give it a color of 3. And don't forget to end the loop. Okay, so let's see if this all works as we want it to. Okay, Control S, hit escape. Let's run it. Have our hand on the arrows. Okay. Okay, I don't see anything growing. Oop. Okay, something's not working right. Oh, of course. We haven't done our growing mechanism yet. So when we do a collision with fruit, that's when we need to grow our snake segment. So let's go down into our fruit here. Okay, so down in our collision. So if we're collided, then we increment the score. What we want to do is we want to go from, so we create another for loop. So we want to go from the length of X table plus 1. Oops. 2 minus 1, do. And what we're gonna, you'll see what we'll be doing here in a minute. So we're taking the x of I equals the x of I minus 1. So we're taking the position, we're taking this the tail piece, the previous tail piece, and we're using that to calculate where to add the next tail piece. Okay, y of I equals, oops, y of I minus 1. And then end. And then this should be working here. Okay, let's try this out. Hit escape, hit run. Okay. Okay, I think we're growing. We're growing. We're definitely growing. Okay, this is cool. All right. So the collision there looks a little bit off. We brush past the fruit there sometimes. You might notice. And yeah, right there. And there. Okay. We'll figure that out shortly. Oh, okay. Let's go back. Now what I want to do is I want to color the snake head a different color than the rest of the body. So what I want to do is I want to, first of all, okay, let's go back and let's put some comments in here. Increment score, not soccer, increment score, and then push new snake piece, new snake tail. Okay, so now we want to draw. In our draw snake function, we have got this little loop here, which does the snake segments. And so the tail, or not the tail, the head, I want to give a different color. And I kind of like that color 10 for yellow. I think that gives it a nice, what we could also do is maybe let's try a bright green. So if you'll notice over here, we got that bright green on 11. I'm not going to click on that. Control S. Let's escape. Let's run it. Okay, we've got a really bright. Okay, well, that's not bad. Really bright green mixed with the coloring of the rest of the snake green. Okay. Let's go back. Well, let's also try yellow because I really like bright yellow. Okay, let's run this. Okay, I kind of like this better. But like I said, experiment away with what we're working on. Use whatever color palette you want and go nuts. Okay, so now we've got this working. What did I want to do next? Let's hit escape. Let's hit escape back to our editor. Okay. What I wanted to do was, when we first start off, I wanted to have like some beginning snake tail pieces. I don't want to start with just the head. That looks like really weird. I've never seen a snake with just the head. Okay. So we're positioning our fruit there. So maybe right here in between setting things up. So let's create another for loop. So for I equals 2, and then let's maybe make it 3 segment pieces long. So you know what? Let's do 5. Let's make it kind of long. And do loop, and then inside the do loop we want to do x of I equals, we'll take the previous piece, divide it by tile size, subtract 1 times tile size. Basically we're pushing on extra our extra snake pieces. So I is the same thing. Y of I minus 1. Or no, you know what? We want to just grow I in one direction. So we'll just use I of 1. And so let's give ourselves a default snake tail length. We're moving in the positive X direction. Start off moving right. Okay, place our fruit is that update function. So let's put a comment here. So place our fruit. Okay, so we're updating our input. We're doing the collision. Let's capture input. Okay, and let's see what this looks like. All right, Control S, escape to save, run. Okay, so we've got a nice, decently long snake piece to begin with. Let's go back to the editor. What we can do is we can create a game over condition when we hit the wall boundaries. So when we hit the boundaries of the outside of the screen. So let's create another is function, and we'll call it, instead of is fruit collision, we'll just call it is wall collision. So function is wall collision. And since our wall is on the borders, all we have to do is check the position if our x of 1 is bigger than 127. I guess it'd be 128. Or our x of 1 position is less than 0, or our y of 1 is less than 0, or our y of 1 is bigger than 128. Then return true. And this time, well, I'll keep it the same. Keep it consistent. Return false. Okay, so if there is, so basically all I'm going to do is I'm going to stop updating. Okay, so if we've hit the wall, then just stop updating. We're going to exit. So if is wall collision, then return. End. Okay, let's see if that works. Hit escape, run. Okay, so we're going to be going along as we do in a snake game. Okay, and then let's hit the wall. Boom. Done. And I think that's all I wanted to cover in this snake game episode. There's a few things I wanted to add, but I think it would make it would be better to separate that out. So here we've got a basically running snake game that you can play with, adjust the variables, play with the position of things. Hey, you know what? Speaking of adjusting variables, let's look at the different tile sizes. Okay, so we chose that we want 32 numbers across. So what happens if we want, not numbers, what happens if we want 16 tiles going across the screen? Is it going to make our snake bigger or smaller? Okay, while you think of that, I'm going to hit Control S, escape. We're going to run it. Whoa. Let's run it again. Okay, that's massive. But that's still pretty cool. Okay, so let's hit escape. Let's go back. Now what happens if we make it 64? Okay, I think it's pretty obvious it's going to make it a lot smaller. Spoilers, I know. So hit Control S, escape. Let's run. Whoa. That's pretty cool. So basically, if we, if we're making any other kind of game, and we want really smaller, we want to stuff more onto the screen, then we could choose this kind of tile size, or pixel size, sorry, to draw the tiles. Okay. Okay, so I kind of like 32. It's kind of a nice medium area, but I'll let you go through the code and figure out for yourself what you want to call it. You know what? And it's up to you to, I'll leave it up to you as an exercise to fiddle with it and have a whole lot of fun with it. I hope you really enjoyed this video. Share it with your friends, share it with anyone you know who's learning PICO8, and I'm going to continue this series by adding to this in the next video. So look for it in a few days. Yeah, this is going to be a lot of fun. All right, maybe we'll add a menu or something cool like that to make it look like a real game. Oh, and I'll show you how to export it so that you can play it on a website, or you can download it from somewhere like itch.io or your any other favorite game site that you download games from. Maybe even Steam. Well, I won't show Steam, but it's the same idea anyways. I'll show you how to export the game into something that you can just click and play like every other game that you play on your computer. So my name's Wazoo. Follow me on Twitter. give a like and subscribe to this video, and let me know in the comments what you liked or didn't like about what we went through today. All right, everyone. Have fun with PICO8. Peace.